In this video, we're going to discuss finding slope from a graph. So as a quick reminder, slope is the change in y over the change divided by the change in x, or rise over run, vertical divided by horizontal, any of those things. Given that this graph is linear, we can pick any 2 points. So I'm going to pick right here, pick the points 0, 8, and 1, 12. And now you have about 3 different ways you can do this, so we're going to do all of them. The first one is to draw that ever lovely right triangle to show your rise over run or your fall over run. But it is so important that you read the graph and you don't just say 1 box up, 1 box over, because I'm going from 8 to 12. And I get from 8 to 12 by going up 4. And from 0 to 1, my change is 1. So that makes our slope, just looking at the table, 4 over 1. 4 inches of growth for 1 day, per day. 4 inches per day is the rate of change of this banana tree. If you think you're going to mess up and you can write these points, you can use the formula. y2 minus y1 over x2 minus x1. So let's look. We have x1, y1, x2, y2. So we have 12 minus 8 divided by 1 minus 0, which equals 4 over 1. Same answer. Now, I personally mess up when there are negatives involved. I'm just being honest. So, I like to put my 2 points onto a table, an x, y table. And I figure out that 0, something gets me 1 plus 1. Or my difference, my change from 8 to 12 is plus 4. And if I look at the change in y over the change in x, then surprise, surprise, I get the exact same answer. 1, formula 2, table 3 different ways to do these problems. So now let's look at one that finds average rate of change. Again, the only difference is that this graph is not linear. So we're going to use a linear representation between 1915 and 1945. So 1915 is going to be this first dot point right here. And 1945 will be right here. So it's pretty linear, but not quite. And again, we can look at our rise over run, our change in y over change in x. But because it's hard to tell, I'm going to write out the points. 1915, comma, we're at 100. It says in millions, but we read the scale, it's 100. We know that means 100 million. And then 1945, I'm going to say that's around 140. 140 seems like a good estimate for me, knowing that I have to be not quite at 150, but I'm over half. That works. So to get from 100 to 140 is 40. And to get from 1915 to 1945, that's 30 years. So we're looking at a change of 40 over 30. And if we reduce it, 4 over 3. Because this is real world, you could approximate 1.33 million people per year. But in general, you're going to want to keep things as fractions. Once again, you can do the same thing by using these points. 1915 to 1945 under X, 100 to 140 in Y, will still get you a 40 divided by 30. Now make sure when things are real world that you consider that real world context. But otherwise, and you can also use the formula, 140 minus 100 divided by 1945 minus 1915 is still 40 over 30, or 4/3. Any way you slice it, you find graphs, you can do one of 3 ways. Once you have 2 points, you are set.